So, good morning, friends, and welcome to my YouTube channel. So, today's topic of the day is understanding bridges classification and components and key factors and concepts. So, starting, bridges are vital infrastructures components in civil engineering, enabling connectivity across obstacles such as rivers and valleys. Their classification depends on structural designs and material used, directly impacting their functionality and lifespan. This presentation explores bridges types, essential components, and underlying concepts of like economical span and source depth, setting out the foundation of understanding loads and failure mechanisms and bridges design. These technical insights are critical for highway maintenance, safety, and longevity of professionals aiming to optimize performance, safety, and longevity of the bridges assessed under various environmental and local conditions. So, starting with classification of the bridges. So, first is beam bridge, simple construction using horizontal beams supported at ends, typically used for short spans. So, this type of bridges are mostly common in various areas like uh, in mountain region and valley region. So the second type is arc bridges, characterized by curved arcs transferring load to abutments, ideal for medium spans. So this type of bridges are usually seen at coastal regions and bridges like sea links also. So the third is cable and suspension bridges, utilized cables for support, suitable for long span and aesthetic and engineering advantages. So this type of bridges are mostly and most commonly seen in Mumbai, the Sea Link and other bridges. So fourth type is cantilever and truss bridges, employ cantilever arms on triangular frameworks to support weights common in railways and highways. So moving on to the next page. Essential components of the bridges. First is deck, the roadway or pathway where vehicles or pedestrian travel, designed to distribute load efficiently. The types vary from material and loading, such as concrete slab or steel plate decks. The second is piers and abutment, support structural and the transfer loads from the bridge's deck to the ground. Piers are intermediate supports while abutments anchor the bridge at its end. Third is bearings, allow controlled movement and load transfer between superstructure and substructures, accommodating thermal expansion and dynamic forces. So the fourth slide is about concepts of economical span and hydrological terms. First is economical span, the optimal span length balancing construction cost, material used, and structural performance to the achieve efficiency. Second is a flux and high flood level, HFL. A flux is the rise in water level upstream due to the presence of bridge piers. HFL is the maximum regulated water level during a flood event. Third is source depth, measures the maximum depth of the erosion around bridge foundations caused by flowing water, critical for foundation designers. Loads on bridges and IRC load specification. First is dead loads, permanent static loads from the bridge's own weight, including structure and fixed equipment. Live loads, temporary loads from vehicles, pedestrians, and environmental factors specified by IRC code. Third is impact and wind loads, dynamic forces induced by moving traffic, impact and wind pressures affecting stability and safety. Fourth is IRC specifications. Indian Road Congress IRC standard governs load modeling combinations and safety factors for bridge designs. Sixth slide is about bridge failure scenarios in India. Hydraulic failure. Score erosion beneath foundation causing collapse. Afflux increase water pressure beyond design. Second is structural failure. Material fatigue and poor maintenance could cause the same damage. Design indicates against increasing traffic loads. Third is about accidental causes, vehicle collisions, and flood and natural disasters. Preventive measures and maintenance strategies. First is regular inspection, periodic detailed assessment of structural and hydraulic components to identify early signs of deteriorations. Second, scout protection. Implementation techniques like riprap, gabions, and concrete aprons to safeguard foundations against erosion. Third is load management, monitoring traffic patterns and enforcing load limits to prevent overstressing and structural elements. Fourth is timely rehabilitation, repair and strengthen bridge components based on inspection data to extend service life. The last slide is about key takeaways and future challenges. Understanding classification, loads, and hydraulic concepts is crucial for bridge and safe bridge designs. Bridge components must be used and engineered and maintained considering local environmental conditions. Hydrological challenges like scour and afflux require careful evaluation and protective measures. Fourth is adhering to IRC standards improves load resilience and reduces failure risk. Bridge failures in India highlight the need for proactive maintenance and update designs practices. Sixth is future bridges should incorporate advanced materials monitoring technologies and adaptive designs. Continued research, investments, and maintenance and adherence to evolving standards are essential for sustainable bridge infrastructure that withstands increasing demand and climatic variations. Thank you for the day.